Okay. This is new. Chemical reactions and equations. Okay. Chemical equations are a way of describing what atoms and compounds are doing in a chemical reaction. Chemical equations are a way of describing what atoms and compounds are doing. Chemical equations are a way of describing what atoms and compounds are doing in a chemical reaction.
Mister?
Yes.
What does that say right there? It says like what atoms and what?
Atoms and compounds.
Oh, because wait.
And so if we're burning methane, that's what I'm doing over here on the lab table. If you burn methane, one equation that describes what atoms and compounds are doing is this is the formula for methane. When you burn anything, you are reacting it with and combining it or recombining it with oxygen. And you're almost always going to produce some kind of, well, you always, in this kind of reaction, you're always going to produce CO2 and water. Imagine that. We just did models of these things. How about that?
Can you push it down?
Push it down.
Oh, no, never mind. I didn't even know I thought that was like.
Okay.
Bless you. My headphone hurts. Yeah, so does mine. What did you do? What did you do? Oh, what?
Now, I did say one equation because there are other ways of representing this same reaction. Okay, in this class at this time, this is the kind of equation we're going to be dealing with. However, there's a couple more things you need to know. We need to know the physical state of the methane. So if I open up the gas jet over there and don't attach any burner to it, what do you see coming out? You don't see anything. So because of the noise, though, what would you infer is coming out? Some kind of gas. And methane is, in fact, a gas. And we use the symbol G in parentheses to indicate that. Now, any kind of combustion, and burning is combustion, the word in chemistry is combustion. You're always combining some kind of fuel with oxygen. Okay? The other day we burned magnesium. Magnesium then was the fuel. Oxygen comes from where? Where does the oxygen come from for that flame over there on the lab table? From the air. So what physical state is the oxygen in? Now what physical state, not what temperature. What physical state? Huh? Gas. Okay. Huh? Oxygen is most of the time is a gas. That's true. You can make it into a liquid. You can make it into a solid. Can. Well, let me back up the horse just a little bit. They do in fact liquefy oxygen. I'm sure it is possible to solidify oxygen, although I am not aware of it being done. Okay? Now, what physical state is the CO2 in that's coming out of the flame? Must be. I don't see any liquids up there, any solids, do you? You don't see gas all the time. Do you see the gas in the room? Where? No. I'm talking about the whole room is filled with the gas.
I see it on the screen.
That's actually not a gas. That's actually something else.
What is that?
Something else.
What you're seeing on the screen is the result of differences in density for the gases in the room through which this light is shining.
Is that a 2 or just a G number?
That's a G right here. How about the water? What physical state is it in that's coming out of that flame?
Liquid.
No.
Wait, steam.
I don't see. That's right. If it might be steam, that'd be a gas, wouldn't it?
There's water in there? Yeah,
Yes. Anytime you burn a hydrocarbon fuel like this, you have to make water.
I see gas.
That's a gas.
Isn't water a liquid?
No, I mean, you can see it. Liquid, solid, or gas, I guess.
But that's not a liquid you see on the screen.
I know.
Oh, but you don't. What you see on the screen is not the water. It's the water, it's the CO2, and the gases in the room. Okay? What is happening, and this may be a little beyond, what you're trying to ask me. What's happening is, as the heat rises off the flame, it's creating layers of different density above the flame. The light shining through it, then it is bent a little bit through those different densities. It's like bending light through a prism. Okay? Bending light through a prism. You ever seen light bent through a prism? Okay? How many of you ever seen a rainbow? Same basic idea.
Have you ever seen a double rainbow?
Yes?
No.
Huh?
You have double rainbow.
No. It's refraction. It's the same thing as a prism.
What's a double rainbow?
I got that answer right on my test.
It's a rainbow inside a rainbow.
Like, how would it happen?
I'm not sure. I think it's like you have two different rain showers, one behind the other, you know, in such a way that it shines through there and makes two different rainbows.
So this is being recorded.
Okay, listen, guys. Guys, what's your question? Adriana, what's your question? All right. So what you see on the screen up there is not water. At least not liquid water. It's partly steam, but it's also partly CO2 and oxygen and nitrogen and so much the other stuff that's in the air. Okay, it's just creating different densities. Okay, it's kind of like waves in a sense. The sound you hear is due to different densities of air passing over your eardrum. Okay? All right, so G is the symbol we use for a gas in a chemical equation. G is the symbol we use for a gas in a chemical equation. That is an L. Yes.
Oh my God.
Have you taken any notes yet? Don't you think you need to be taking notes? What?